Let's start by going through the steps of what's needed to prepare a residential solar project for permitting. There's a variety of software available to speed up this process, and one of my favorites for small residential projects is SolarDesignTool. A good solar project should not be installed in an area that has significant shading. And partial shading is, you know, essentially resolved through module level panel electronics. So without more further ado, let's get into the design example. So here I am in Solar Design Tool. I create a new project and click go, and then I enter in the site information. Already I can tell that some solar production data is keyed into the same database as PV watts used to develop its energy estimate. So the same weather stations that PV watts keys into, solar design software keys into. Already, Solar Design Tool is asking for some advanced project details, which is why I love this software so much. Although Solar Design Tool has its limitations, it is uniquely focused on creating a final project document that is ready to be dropped off at the local permit office. As such, it's worthwhile to provide it with things like meter numbers and electric service panel information, such that the permit document generated is sufficiently detailed. This kind of project information can only be determined through on-site inspection. So if attempting to perform the design 100% remotely, it's useful to ask the site owner to take enough photographs to provide these details. Here, Solar Design Tool is asking for subpanel information. A subpanel might be used if there are multiple inverters which need to be tied into a single point at the main service panel. While Solar Design Tool has many different configuration options, it may not have the exact configuration for a particular job site. So in many cases, it will generate a permit-ready document, but sometimes minor changes are necessary to be completed in an external CAD software such as AutoCAD or DraftSite. So if you don't know some of these terms, such as the difference between a top-fed service panel or a center-fed service panel or a main lug only service panel as opposed to having a main breaker, then you might not be competent enough to perform this level of solar design detail, at which point you should consult with an electrician to complete these steps. Other project information is inputted, some which is technical. This can be omitted, but there is no reason why this level of detail cannot be established at the front end of the project. Then pulling this information together, such as knowing who your local authority having jurisdiction is or what version of National Electric Code you're on, it allows for a more successful project altogether. Site conditions inputted include local building code and wind speed, surrounding terrain, which will then be called out in the final permit documents. This information is used when using manufacturer provided sizing tools, such as racking sizing software or even inverter circuit sizing software. So at this point in the project design process, this information should already be known. Now the next step is it's asking us to draw out the rooftop. And there's a few options to do this, ranging from simply inputting the dimensions of the installed area to tracing over an aerial image, like overhead map, to actually buying a mapping service to do the heavy lifting for you. So depending on what you're already purchasing, you may already have a 3D model. But the most common premise for a starting point for solar design software is that the array will be developed by tracing over a satellite image. So later we will explore some other options where satellite images found on Google Maps may be insufficient. But at any rate, here's the job site. It's immediately apparent that there is a large southern oriented unshaded roof surface uh, that is a ideal roof surface for a solar project, although it might be worthwhile to consider solar on the west facing roof surface and even on the north facing roof surface depending on the roof tilt. um, Other kinds of solar design software are better at determining the roof tilt than SolarDesignTool. Even so, toggling the street view and the tilt view can provide enough visual detail to attempt a guess at the roof tilt, as well as identify other rooftop objects. Now it's time to define the area of the southern roof, which is a simple matter of pointing and clicking around the roof surface with a double click when complete. The orientation of the roof is then specified. We are then prompted to enter the roof pitch. So this process is then repeated for all the roof surfaces. So how accurate do these roof areas need to be? It depends. Many jurisdictions require a 3-foot offset from the roof ridges and rakes, which are the sides and the tops of the roof. For structural and accessibility reasons, it is even better to stay 4 feet off the sides and off the top of the roof. This would give the installation a nice margin of error by reducing the need for careful site layouts. However, roofs with more substantial penetrations may require more accurate planning. Um, for most solar design software, the procedure is to define the usable roof areas first and then add on any obstructions second. So here we've mapped out different obstructions on the rooftop. These pre-existing holes in the roof, chimneys, plumbing vents, valleys that are shingled over or flashed together. These pre-existing holes uh, become common leak hazards after the solar array is complete. This is because most workers on the roof are stepping on these locations. A risk that is increased, particularly with a compact array design. At any rate, the clearance areas around a chimney, around a plumbing vent, or around a roof cap can become walkways, and they might need to be repaired at some point in the future. So it's best to allow for some clearance around these obstacles, even when the clearance is not required. There are exceptions. An ugly solar array does not add as much value to a home as a pretty solar array. So if the array's look is significantly improved by putting a solar panel a little bit closer to that chimney, it may be acceptable so long as the client understands the design decision. In any event, clearance space around the chimney is more important than clearance space around a plumbing vent, and staying clear of these obstacles kind of removes the need for nuance. So it's time to locate the equipment. SolarDesignTool is asking the designer to locate the main service panel, utility meter, as well as any sub panel or disconnect switches. Google Street View is your friend here, as it tells you, where the meter location is without having to step foot on the site. Of course, this information can be picked up in a site evaluation or by simply chatting with the client. SolarDesignTool is asking for the building's least horizontal dimension Useful for engineers in determining wind load, although this typically is resolved from over engineering the racking or offsetting the array from the roof edges to mitigate wind load. Google Earth, with its built in ruler tool, can be useful in quickly measuring this dimension. In this case, the building measures 50 feet wide. These are roof and rafter questions, which again is information supplied via a site visit. But anyway, we've sketched our roof, and now we are presented with three defined roof areas to lay modules onto. This menu is similar to using a manufacturer's string sizing tool combined with an array layout generator. It's not as nuanced as other solar design softwares. So sometimes it's best to do the shade analysis and array layout in a different solar design software before importing the design or remodeling the design within SolarDesignTool. After selecting your module and your inverter, you're presented with your circuit configurations. This is a microinverter design, and the microinverters, per their specification sheets, are limited to 17 modules per circuit for this particular module on this particular inverter, and it gives us different branch circuit configurations. The north roof gets 17 module circuits and very long, even circuits. The south roof, the circuits are kind of divided up to make the installer's job easy. So in this example, I'm taking a 320 watt black on black 60 cell module combined with a DC optimizer inverter system. Taking a quick look at my array layout, I can see that 31 modules fit on the south side of the rooftop. Um, I'm a big fan of ordering by the pallet. And so here we have in a portrait orientation, I can fit 31 modules on the roof. Uh, or if I use a landscape orientation, I can fit 29 modules on the rooftop. That's not the end of the story. I'm a big fan of ordering by the pallet. So I find that ordering pallet quantities of solar is the best way to work the supply chain. Likewise, portrait mounting makes quick and easy work on a shingle roof. Because of how the rafters and purlins are laid out on a metal roof, it can be the opposite way. And so in Australia, they have a lot of metal roofs. They do a lot of landscape orientation. In the United States, we have a lot of shingle roofs. We do a lot of portrait orientation. In some cases, landscape can be the better choice. Aesthetics can fit into it well. But for this particular solar panel, looking at the spec sheet, one pallet of panels comes with 25 solar panels. So if my client only has budget for one pallet of solar panels, I can easily fit 25 solar panels on the south side of the roof, regardless of whether or not it's in a portrait or landscape orientation. Here's a project example that would be a very easy and not too ugly of an install, where I can fit 25 solar panels on the south side of the rooftop. Um, and so if I'm just going for a low budget, fast, easy one pallet installation, this is probably the array layout I would end up with. So I can fit 33 solar modules on the roof, maybe 32. I can fit more modules on the rooftop in a different orientation. And so if I wanted a larger system, if I was doing a two pallet solar design, um, I'll look at the south side and the west side of the roof uh, in a more compact frame to fit everything in a aesthetic manner. Although it would be a more difficult installation. An installer might, in a more active market, may design to have this kind of best fit system to the roof. In a cheaper market, with lower project costs, they might go for an easier solution that covers, all three surfaces of the rooftop. And, that empty space allows you to make some minor adjustments for array aesthetic considerations and maintain the portrait orientation that makes for an easy install. Um, aesthetics and ease of installation are also important in your array layout, as well as how many solar modules can you fit on the rooftop.